this video is going to address how to find the inverse of a 2 by 2 matrix. And the first thing I want to talk about is in a regular equation, say we have an equation that looks like this. In order to get rid of the 2, we have a choice. We can either divide both sides by 2 and solve for x. 2 divided by 2 is 1, so this doesn't cancel out, it becomes the number 1. Or we can choose to do the following. We can multiply both sides of the equation by the multiplicative inverse of 2. The multiplicative inverse of 2 is the reciprocal of 2. And when we do this, we get the same exact result. Okay, so in multiplication, we can multiply by the multiplicative inverse of a number to have it divide out to 1. So in this case, 1/2 times 2 divides out to the number 1. And we can get rid of the 2 by using multiplicative inverses, or in an equation we can divide by the number we want to get rid of. In matrix equations, you can't divide by a matrix. There's no such thing as dividing by a matrix. So you have to multiply both sides by the multiplicative inverse of the matrix. And how do you write the multiplicative inverse? Well, if I have matrix A and I want to say find the inverse of matrix A, I would write it like this. Or I could write it, that's equivalent to saying, writing the matrix itself with an exponent, what looks like an exponent of -1. Okay, the exponent of -1 says find the inverse of this matrix. So how do you find the inverse of this matrix? Well, let's go ahead and walk through the process. Well, the inverse of matrix A. The first step is to augment my matrix with my identity matrix. My 2 by 2 identity matrix. So I always have to augment my matrix with my 2 by 2 identity matrix. My goal is to turn the left side of this matrix into my identity matrix, and the right side will end up being my inverse. Alright, so how do you do that? Well, if you can remember in chapter 4 when we solved systems of equations using matrices, we were given operations that we were allowed to use on the matrix to solve the equation. So we're going to use those same operations that we used in chapter 4 to change this matrix into the inverse of this matrix. Okay, so the very first thing I do is I'm going to draw my diagonal in, and I'm going to start with column 1. I'm going to circle the number on column 1. I'm going to say, how am I going to use 1 and 3 to eliminate the 3 in this position? Because I need to turn this into my identity matrix, I need 1s along my diagonal, and my identity matrix has 0s in all the other positions. So this 3 and this 2 need to be 0, the 1 and the 4 need to be turned to a 1. So I'm going to go ahead and put my matrix first in row echelon form. So I'm going to use the 1 to eliminate the 3, and I'm going to do that by multiplying the first row by -3 and adding it to the second row. When I multiply the first row by -3 and add, I get 0. And then -6 plus 4 is -2. -3 plus 0 is -3. 0 plus 1 is 1. Alright, so then once I have a 0 in my first column in place, I am then going to draw my diagonal, and I'm going to work on column 2. I'm going to circle the number on column 2 and ask myself, how am I going to use these two numbers to eliminate this number up here. So this one's easy. If I just add row 1 and row 2 together, it eliminates that number. So I'm going to add row 1 plus row 2, and I get 1 plus 0 is 1, 2 plus negative 2 is 0, 1 minus 3 is a negative 2, 0 plus 1 is 1. So we are almost there. Okay, so again, just like in chapter 4, we went through columns, and we start in column 1 and we eliminate the number underneath. Once we do that, we move to column 2 and eliminate the number above the diagonal. And our very last thing that we did in chapter 4 was to divide by the number on our diagonal in order to make the numbers in our diagonal 1. So we're going to do that again. I'm going to take row 1 and do nothing to it because that number is already a 1. But I'm going to divide row 2 by a negative 2. And when I do that, what I get is 0, 1, 3/2, and negative 1/2. Okay, my inverse of matrix A is negative 2, 1, 3/2, and negative 1/2. My inverse is always what ends up on this side of my matrix after I'm done converting. So how can we test to make sure that we have the inverse correct? Okay, so I'm going to erase the left-hand side and I'm going to test to make sure my inverse is correct. Just as in math, if we have two numbers that are inverses and we multiply them by each other, 2, the inverse of 2 is 1/2. When we multiply, we get a 1. 1 is the multiplicative identity. The multiplicative identity. So the same holds true with matrix multiplication. When you find an inverse and you multiply a matrix by its inverse, you should get the multiplicative identity. So I'm going to go ahead and multiply 1, 2, 3, and 4 by my multiplicative inverse, and I better get the identity. So when I multiply, I'm going to bring up this first column, negative 2, and then 3/2. When I multiply, I get a negative 2. I'm going to add to that 6/2 or 3. Now I'm going to do my second row. Negative 2 times 3 is a negative 6. 3/2 times 4 is 12/2 or 6. Now I'm going to pull out that second column just to test. I pull out a 1 and a negative 1/2. So multiply 1 times 1 is 1. Negative 1/2 times 2 is negative 2/2 or negative 1. Now the second row, 1 times 3 is 3. Negative 1/2 times 4 is a negative 2. And when I simplify, I want you to notice I get my identity matrix. So we can't just test one way since matrix multiplication is not commutative. We have to, just to be sure that we have the correct inverse, we have to multiply my inverse on both sides of my original matrix. So this time I'm going to multiply it on the left side, and I should still get my identity matrix. I'm going to pull out my first column, 1 and 3, and when I multiply, 1 times negative 2 is negative 2. I'm going to add to that. 3 times 1 is 3. 1 times 3/2 is 3/2. I'm going to add to that. 3 times negative 1/2 is negative 3/2. Now I'm going to go ahead and pull out my second column. 2 and 4. Multiply. 2 times negative 2 is negative 4. 4 times 1 is 4. 2 times 3 halves is 6 halves or 3. 4 times negative 1 half is negative 4 halves or minus 2. And when I simplify, I get a 1, a 0, a 0, and a 1. I get my identity matrix. So when we solved for the inverse, we solved correctly, and my inverse is, the inverse of matrix A is negative 2, 1, 3 halves, negative 1 half.